standards retakes. This first question has radical 5 and radical 5 in common. And when we have things in common, we want to put them together. So what we did here is we moved negative 3 root 3 and 4 root 5. We exchanged their position using the commutative property. We can do that because it says in commutative property over addition and subtraction that we can move the terms around. And that's exactly what we did. 3 root 5 now plus 4 root 5 minus 3 root 3. And now these are like terms. And now these are like terms. We have 3 root 5 and 4 root 5. And that adds up to be 7 root 5. Just like as if we were asking you to add 3x and 4x, you would have no problem with that. You'd get 7x. But in this case, we're asking you to do 3 root 5 and 4 root 5. Again, the root 5 is in common. 7 root 5 is what we get. And then we're left with negative 3 root 3. Can we do anything with that? No, we can't. Root 5 and root 3 are not in common. And there we go. So there's our first answer. Again, 7 root 5 minus 3 root 3. We can't subtract 3 root 3 from 7 root 5 because root 5 and root 3 are not like terms. They're not in common. The second question, 3 root 5 times 6 root 2 minus 4 root 3. For this question, we are multiplying now. We are multiplying, so we distribute. And we go 3 root 5 times 6 root 2 minus 3 root 5 times 4 root 3. Since we're multiplying now these terms here, there's a little bit of a different thing going on. What we do is numbers to the left, radicals to the right. So we're multiplying numbers, 3 times 6, and radicals to the right are being multiplied together. So I'm rearranging things again with the commutative property, and then moving numbers to the left, radicals to the right. We're still multiplying, so we get 18 root 10. And then over here, minus numbers to the left, 3 times 4, radicals to the right, root 5 times root 3, minus 12 root 15. Now, can we do anything else with that? Can we simplify? Well, root 10 breaks down into root 5, root 2. There's no perfect square, no double. Nothing we can do to simplify. Root 15 is similar. Root 5, root 3 can't be broken down anymore. There's no perfect square, no double. And can we, 18 root 10 minus 12 root 15, we're subtracting here just like we were up here. But as we couldn't simplify anymore up here, 7 root 5 minus 3 root 3, we can't simplify anything here because it's root 10 and root 15. They're not in common. So we are done with that question. There's nothing else we can do. Any questions out there? Now the next one, number 3, simplify root 48. On this one, we're looking for perfect squares and doubles. We want perfect squares and doubles to end our radical troubles. And perfect squares and doubles to end our radical troubles. Root 48 is equal to, now the best way to do this, there are 2 different ways to go, or maybe even 3, is to go root 16 times root 3, because 16 times 3 is 48. Root 16 is 4, 4 root 3 is our answer. That was easy. That's the express root. But some people may not realize that, and they may go, okay, well, I know that's 8 times 6, so I'm going to go root 8 times root 6. And then you're going to wonder what to do. Well, again, I'm looking for perfect squares and doubles. That's what I'm looking for. So we've got root 4, root 2, root 2, root 3. This is equal to root 2, root 3. That's equal to root 4, root 2. We have a double, and we have a perfect square. That perfect square is 2. That double is equal to 2. And this is root 3. And we get the same answer. We just have to work a little harder to get it. So it's not that you can't, if you don't see the perfect square that's bigger, in this case 16 times 3, then you're still okay, but you have to work a little harder. Break it down, look for perfect squares, look for doubles, and you'll succeed. You just have to get used to recognizing where the perfect squares and where the doubles are and then how to deal with them. Remember, when you have a double, it's the same as saying root 2 times root 2 is equal to root 4, which is equal to 2. Shortcut would be to just say, okay, whenever I have a double, I just take the number that's written and I put it down there. Last but not least, these ones here are fractions, 5 over root 5. And in this case, you cannot have a radical in the fraction. You can't have a radical in the bottom, the denominator. So you do what's called rationalizing the denominator. You multiply by root 5 over root 5. Okay, which is actually, in effect, this is actually 1. Root 5 divided by root 5 is equal to 1. And that means we're not actually changing what's really happening here, is we're not actually changing anything, but we are changing the way it looks. And here's why. Because root 5 times, 5 root 5 is on the top, okay? And root 5 times root 5 is a double, so it's equal to 5. And then we've got a fraction. The 5 divided by 5 is equal to 1. And we end up with root 5 as our answer, okay? And we're done. Now, are there any questions? Anybody out there? No? Okay, thank you very much. We'll have standards retakes, more videos coming up.